Question 4 is coming from circular measure. The diagram shows a triangle OAB where OA is equal to OB is equal to 10 centimeters and angle AOB is 0.8 radians. Points C and D on OA and OB respectively are such that the arc CD is part of the circle with the center O and radius 6 centimeters. The shaded region is bounded by the arc CD and the line segments CA, AB, and BD. Part A, find the perimeter of the shaded region. Now, to find the perimeter of the shaded region, we need this arc here. Remember, perimeter is the sum of the lengths around the shape. So I'll need the length of this arc CD, then this length here, and then this one here. Okay, so that is what I'll need. Now, since this is a triangle and I have this angle, to find area of a triangle which is not right angled, so long as I know this part and I know this part and then the angle, the area is going to be a half A times that B, then sine of the angle in between. Okay, so that is that. Now we are going to have the perimeter of shaded region. It is going to be equal to arc length CD plus AC, it's a straight edge, then plus AB, then plus BD. So arc length, we know it is r theta. Now when you come to this number of circular measure, you turn your calculator to radians straight away, because if you are using the arc length as r theta, then you are supposed to use radians. Otherwise, the length of an arc is equal to theta out of 360 degrees, then times, because an arc is part of the circumference of a circle, then we say times 2 pi r. But then in radians, 360 is 2 pi, so times the 2 pi r here. You can see that this one disappears, then you get r theta. Okay, that is the arc length. Okay, it will be that in radians. That is where it is coming from. And then also area of a sector. Area of sector is going to be this sector here. That theta divided by 360 times 2, not 2. A sector takes a portion of the amount of space occupied by the circle. So we multiply by the area of the circle, which is pi r squared. Again, 360 is 2 pi, then times this pi, then r squared. This one can go, and then you remain with a half theta r squared. We can write r squared theta, you see. So your calculator has to be in radians for you to use this formula or this formula here. We are going to write our r for this arc here. The r is 6, and then the theta is 0.8. 6 times 0.8, then plus AC is 4. Then AB, since I know this length here, and the angle in between, and they are asking me of this side here, which is opposite to this angle, I can use cosine rule. If a triangle is not right angled, that is where we can use the cosine rule and the sine rule. So remember, the cosine rule is a squared is equal to b squared plus c squared minus 2bc, then cosine of a. So I'm going to put it here, and I say my a squared, that is our AB, which is, but then at the end of it all, I'll take the square roots. Okay, so square root of this is 10 squared plus 10 squared. So 10 squared plus 10 squared, then minus 2 times 10 times 10, then cosine of the angle which is opposite to AB, which is 0.8. And then BD, is also 4. Then here, all together, let me first simplify this. 6 times 8, that is 48. So this will be 4.8. Then 4 plus 4, that is 8. So 8 plus 4.8, that is 12.8. So I write this one as 12.8. Then plus now the square root. This is 100 plus 100, that is 200. Then also this one is 200. Then cosine of 0.8. So altogether, when we put this one in the calculator to 3 significant figures, what we get? My calculator here is in degrees, so I need to change it to radians. I will press shift, then mod, radius 4, and then now you can press 12.8 minus, now plus, the square root of 200 minus 200 cosine of 0.8. The answer is 20.6 to 3 significant figures. Centimeters to 3 significant figures. Then part B, find the area of the shaded region. So I'll get area of the triangle, then I'll subtract area of the sector. By the way, we can also find AB this way. I can split this one into 2 and then it becomes a right angled triangle. Okay, I can split it into 2 that way, and then remember I want this length here, so this is a half of AB. Even this one is a half of AB. And so that means this angle here is going to be 0.4 and this one 0.4. Then we can say that, so I'm trying to write something here. Let me in fact rub off this. There are many ways to do this one here. So if I say this is an alternative approach, alternatively, we can have, this is 0.4, this is the opposite side to it, and then this is the hypotenuse. So I can use sine. Okay, sine of 0.4 is equal to a half of AB. Sine of 0.4 is equal to a half of AB. Then we divide by the hypotenuse, which is 10. Now when we cross multiply, of course this a half, this 2 here, now we'll multiply with the 10 here. It becomes, it will be AB over 20. So when you cross multiply, you'll have 20 sine of 0.4, which will be equivalent to AB. Now, what will be the perimeter? So perimeter is going to be equal to, remember this one is 4.8, then plus, this is 4 and a 4, that is 8, plus 8, then plus this one that we have gotten here. Okay, in fact, let me take this one away from here. So perimeter is going to be that, then plus the 4, then plus now this 20 sine of 0.4, then plus the 4. So what do we get here? 4.8 plus 4 plus 4, then plus 20 sine of 0.4. Remember, the calculator has to be in radians. Do you see that we get the same answer? 20.6 centimeters. So you can use this one, or you use this one here when you are finding the value of AB. Now, next, find the area of the shaded region. So the area of the shaded region, I'll get area of this triangle, then minus the area of the sector. So area of the triangle, let me write this, shaded area is equal to area of the triangle triangle OAB minus area of sector. The sector is OCD or CD. Now area of the triangle, it is going to be a half AB sine C. I told you that before. So the A is this one, the A is this one here. The B is this one here. Then sine of the angle in between, that's 0.8. So I have times 10 times 10, then sine of the angle in between, which is 0.8, and then minus area of the sector is a half r squared theta. And the r, for this small sector here, the radius is 6. So times 6 squared, then the theta is 0.8. Then we can put all of this in the calculator and we get the answer. But first I can simplify this. This will be 100 over 2, which is 50, sine 0.8, then minus, this is 36 divided by 2, that is 18, into 0.8. So what do we get altogether? 50 sine 0.8, then minus 18 into 0.8. That is 21.5 to 3 significant figures, 21.5. This will be centimeters squared to 3 significant figures. Alternatively, you could find the area of the triangle here. You first find the area of this one here. So a half times the base. The base is this AB here. And then the height. You don't know the height. So since you know this one as 10 and you know this one here, you can use Pythagoras theorem to find this one, or you can use maybe cosine. Cosine of 0.4 is equal to adjacent here, then divide by the hypotenuse, which is here. So whichever you want, but that is that.